Hello and welcome to a new video. So this is a part of my Algebra 1 series. We're still talking about solving linear equations. This is my 5th video in this series, and it's going to talk about solving special cases and checking answers. And I think both of these things are helpful for those times when things seem to get a little weird. If you'd like to follow along, I have a notes page you can download. Just click the link in the description or the link that hopefully will appear up above my head somewhere around now. Let's start off with a nice warm-up. So hopefully this is a kind of problem that you have seen before in pre-algebra, and so it's not too tough for you to do. But that being said, if you find yourself struggling, just continue watching. If you want to give it a try yourself first though, please pause the video and start it back up when you're ready. Okay, I'm going to assume you're ready. So we're being asked to evaluate an expression in each of these problems, and we're also told that x equals something. So what we can do is we can put what x equals where the x is, and then evaluate means find an answer for, basically. We use that word a lot in math, in like math textbooks or in math worksheets and things like that. Evaluate just means, work with this and try to get an answer. So here's what we're going to do. We're going to take this 2 and put it where this x is. So I'm going to do 2 times 2 plus 5. Now I got to make sure I do correct order of operations here. What I mean by that is that multiplication needs to happen before addition. So I'm going to do 2 times 2 first, and then I'm going to add 5. 4 plus 5 equals 9, and that's my answer. If you got that right, good job. If you didn't, hopefully you learned something. On the second one, if x equals -5, evaluate, and this time we've got an expression that has parentheses. The first step here, if you're thinking about PEMDAS, this kind of adds a step at the beginning. We go ahead and we put in this -5 first because it can change what we're able to do and what order. Because if we don't put the -5 in, you might be thinking, I'm going to distribute, and that's fine. You can distribute, but you don't have to if you plug in the -5 right off the bat. Let's take a look. -9, and then where x is, I'm going to put -5. So I'm going to do -5 plus 1 in the parentheses, which gives me -4. And if you just still wanted to distribute, that's fine. The distributive property works. That's kind of the whole point of it. We just didn't have to use it if we realized we could combine those numbers like the normal way. -9 times -4 is positive 36. Remember, two negatives, when you multiply them together, give you a positive. The negatives are like, peace out, I'm going to go play a video game, and you guys can do math without me. So it's positive 36. We got 2 types of problems coming, and so this warm-up is going to actually help us more on the second one than on the first one, but hey, it's whatever. If you watched my video previous to this one, 1.4, then at the end there was a challenge problem. We were solving multi-step equations, and then I left with this problem and I didn't say what the answer is. So now we're going to explore what happened. So if you did this challenge problem, hopefully you kind of remember, and we can talk about, well, not talk about, I'll talk about what's going on. So if I distribute this -5, I get -10x minus 40. And then I can distribute this -10, and I get -10x, and I get minus 40. And then if I add the 10x to both sides, I notice a problem. You may notice a problem already, actually. -10x minus 40 equals -10x minus 40. If I try to put the x's together, though, I run into a problem. Because when I add 10x on both sides, that goes away and that goes away. And now I have -40 equals -40, and I no longer have an x. This is what is called a special case. And so let's talk about special cases, and let's figure out what this means. Okay, linear equations, which is what we have been solving up until now, they can have 3 types of answers. And once we learn about other types of equations, we'll learn what kind of special cases they have. They may be the same as this, they may be a little different. It depends on the type of equation. But our linear equations that we've been solving, they actually have 3 possibilities, although I purposefully have only given you one of these situations up until the challenge problem on 1.4. So the first possibility is that we get a unique solution. The word unique means one of a kind, or, something that's not really repeatable, that kind of thing, right? So a unique solution is when we get x equals a number, and that's the only thing that works for that equation. When you solve an equation like normal and you end up at the end with x equals a number, you've got a unique solution. Even if you're like, this is the 5th time I've got x equals 1, that's not what we mean by unique, that, you get different answers every time necessarily. It means there's only one number that works. As opposed to, there are equations that actually don't get an answer at all. And what we do is we have a special way that we kind of say that as mathematicians, we all agree that this is a great way to say it to get the point across what we mean. And that is the second option, no solution. When we're solving equations, we're trying to get solutions. So if we don't get a unique solution, we could get no solution at all. There's nothing that works for that equation. That's going to happen to us, and we're going to see how that happens. And the third one is that we could have infinitely many solutions. And in the case of linear equations in particular, that means that our solutions are actually all real numbers. So infinitely many refers to the idea that there's a lot, right? Too many to count. Infinite means too many to count. Infinitely many solutions means there's too many solutions to count. And that actually is because for these types of equations, you could literally pick any real number and it would work. And so that means you could pick 1, you could pick 10, you could pick 0, you could pick pi, you could pick the grossest decimal or fraction that you possibly can think of, and it would work. It would fit into that equation and maintain equality between the two sides. So the second and third option here, those happen in cases like what we just had where our variable cancels out. And the next thing we do when our variable cancels out like that is we look to see if what's left is a true statement or a false statement. So we ended up with negative 40 equals negative 40. Well, that's true, right? Negative 40 does equal negative 40. When you get a true statement, that's going to be your sign that you have all real numbers as an answer. So you could write true statement. Okay, that means I'm going to write all real numbers for my answer. For no solution, we're going to see a false statement. So getting things like you get to the end and it says 0 equals 2. Well, 0 does not equal 2. So what that means is that no matter what number you plug in for x, you're not going to get a true statement, so there's no solution. So we are now going to do some examples of how to do this, and it's going to be a really good time. All right, example 1. We've got an A equation and a B equation. If you are guessing that one is going to be one type of special case and the other is the other type, way to go. You figured me out. So actually, most of the time, our equations that are going to give us special cases will be more complicated than these, just because once you realize what you're looking for, it's really easy to tell that these are special cases. So for whatever reason, and I mean, I do it too, it's more fun if it takes you like at least one step to be like, oh, this is a special case, instead of just knowing right off the bat. Maybe that's just me. I don't know. So in both of these cases, we could either, we could go ahead and subtract 10x from both sides and then see what we're left with. So let's try that here. Minus 10x, minus 10x. Okay, so our x's cancel. That's what our red flag is as far as knowing this is a special case, is that, hey, those x's went away. Then we look at this and we say, is that a true statement? Does negative 1 equal 2? No, it does not. And that means that we say no solution for our answer. Now, looking back at the beginning, if you have 10x minus 1 and 10x plus 2, hopefully, maybe not now, but maybe at some point you're like, well, wait, that totally makes sense why nothing works for that. Because if you're going to times something by 10 and do different things to it after that, well, how could you get the same number? If I times by 10 and then subtract 1, I can't get the same thing if I times by 10 and then add 2 as well, right? So at some point, maybe once you get to that step before you actually subtract, you'll realize that it's no solution. And then B, we can again do minus 10x on both sides and see what happens. But also, if we're really paying attention and looking, we can say, okay, wait, if I have 10x minus 1 equals 10x minus 1, if I pick any number I want to, doesn't that have to be true? 10x minus 1 will always equal 10x minus 1. And I almost feel like I should go back to a normal equation and point out, like, it's not so obvious that they're equal, right? Let's say if we have 2x plus 3 equals 7, right? Is it obvious that those are equal? Well, I would argue no. We have to do some figuring out. You may be able to figure out in your head. I'm not saying you can't, but it takes a little bit more effort to be like, yeah, okay, I can see how you can make 2x plus 3 equal 7. It's by choosing a certain value for x. Well, on B here, they're already equal. So you can literally put in anything you want and have it be an answer. Now, if that doesn't float your boat, if you still want to subtract 10x from both sides, I'm happy to do that, because then we get to do this thing where we're like, negative 1 equals negative 1. Is that true? Yes, it is. Now here's what we do to write our answer, is we say that our answer is all real numbers. And I tend to get students a bit complainy at this point, because they're like, do I really have to write out all real numbers? And I normally say, yes, yes you do. I would like for you to write out all real numbers, and I would like for you to write out no solution, because these are our accepted answers for these situations. That'd be super cool. Do it. All right, example 2. Now this is what I mean by them making it a little bit less obvious that we've got special cases going on. And so it might not even be true that these are special cases. Maybe I, tried to throw you off and they actually work out to be unique solutions. We won't know until we try, right? So we're going to go through the same process we did in 1.4 with multi-step equations, where we distribute to get rid of parentheses, we add like terms if we have them, and then we follow our order of operations for equations, which remember is not exactly the same as it normally is. So I'm going to start by distributing this 4 and get negative 20x, and then plus 4. And I'm going to distribute this negative 2, so I get negative 20x plus 4. And as I said in the last one, this is the point actually where you could stop and say what the answer is if you realize it. If not, if you don't realize what the answer is yet, keep going and add 20x to both sides. And then that gives us 4 equals 4. Is that true? Does 4 equal 4? Yes, it does. So our answer here is all real numbers. If this, by the way, I don't know how much you would have heard the term all real numbers before at this point, but if you've ever heard this term and thought, does that mean there are some numbers that aren't real? That is a great question. And you know what? I'm not going to tell you, because you need to get farther in math first. Okay, all right, B. We've got this lovely equation that obviously looks completely typed and not at all like I messed up and had to change it and re-record, but it's fine. Let's distribute and do all that stuff. So 3 times 6x is 18x, and 3 times 4 is 12. Don't forget about this plus 1. Then we're going to come over to the other side and distribute the 2, so that we get 2 times 9x is 18x. 2 times 5 is 10. Let's add this perfectly normal looking 4. And let's continue. Let's do the 12 plus 1 and the 10 plus 4. So that's a plus 13. and a plus 14. It could be that this is the point where you know the answer. It could be you need to go a step farther. Either of those is fine. So, whichever way you do it, hopefully you can say now with confidence that because 13 equals 14 is not a true statement, there is no solution to this equation. Now you try. So solve these equations and see what you get. They could be special cases, they might not be, but pause the video, give it a try, start it back up, either when you have an answer or when you get stuck, so that you can get past where you get stuck, if that's what happens. Go. Welcome back. We're going to solve this first equation. There's nothing I need to do on the left because there's not a parentheses, but on the right I need to do 2 distributed into the parentheses. So 2 times negative 2x is negative 4x, and 2 times 1 is 2. And so we do have like terms here on the right side. I can add 2 and 5 together, so let's do a rewrite. And this could be the place where you're like, oh, I know the answer. Or it could be you decide to go ahead and add the 4x to both sides. And then we look at this, we ask ourselves that wonderful question. Is negative 7 equal to positive 7? And this is one that could trick you, because you could drop a negative and have them be the same, or you could just not be paying attention, or you could accidentally convince yourself that negative 7 and positive 7 are actually the same thing, which they're not. And you could pretty easily accidentally say this is all real numbers, but it's not. It's no solution, because negative 7 does not equal 7. Let's look at B. Distribute. Oh, if you were stuck on the first one and then you learned something, go ahead and pause the video, try the second one again. Let's see what we've got. So distribute. 6 times negative 4x is negative 24x. 6 times 2 is 12. Distribute on the other side. Negative 3 times 8x is negative 24x. Negative 3 times negative 2 is plus 6. So make sure you don't forget about this plus 6, especially if you distribute and then think that plus 6 is the other plus 6. You might forget about it. Anyway, so this is negative 24x plus 12 equals negative 24x plus 12. This may be the point where you go, I think I know the answer. Or it may be that you go a step further and add 24x to both sides. Either way is fine. So we get 12 equals 12, which is all real numbers. I am hoping that this seems pretty straightforward, pretty easy, because in some ways you get to stop the problem earlier, right? Because you can actually get to the point where you divide by what's in front of x, which usually is something that happens in our equations. So in some ways it's a little bit easier. Now normally you would have some of these mixed in with other equations so that it might catch you by surprise. So that's one of the ways this can be trickier. But I do have something that's going to help us in general with being more confident about our answers. And that is the idea that we can actually check our answers. I'm not going to go on a long-winded tangent about this, just a short-winded one. But one of the things I like most about math is that, for the most part, there's a correct answer that everybody can get to if they know what they're doing. We can check all of our answers when we're solving equations, and especially these linear equations we've been doing. It's super duper easy. Now, it can be tedious and feel kind of pointless, especially if you have solutions given to you by your wonderful teacher. So this is really more of a thing of we should practice it some just to make sure we can do it, but the time to use this skill is actually when you have high stakes of getting it right. So on something like a quiz or a test, you'd want to, go that extra step. And then the other time to use it would just be if something feels off about your answer. I don't know what that might be that feels off, but if something feels off, you know, just throw it back in, see if it works. So we're going to do this. There's two of these, so starting with the first one, x equals 5, a solution to the equation 2x plus 3 equals 13. And I also think this might help us, if we didn't already understand what was happening here, to understand a little bit better. We're going to take the 5 and put it where the x is. This is where our warm-up is going to come in. And what it's asking us is, do these two sides actually equal each other? Because that's what's supposed to happen in an equation. They're supposed to be the same thing on both sides. So it's asking, is 5 the number that makes this work? And so we're going to work out the left side. 2 times 5 is 10, and then we've got 10 plus 3, which is 13. So yes, x equals 5 is a solution. If we work it out and it's not something that gives us an equality, then that would mean that that is not an answer. So if you do solve an equation and decide to check it and what you get doesn't work out, you need to go back and see if you can find your mistake. When you do that on a test though, if you get something and you're like, I think that's wrong, I would encourage you not to immediately just erase the whole thing and instead to like move over to a different part to work it out, because if you just end up not being able to get an answer, it's better to have work down to show the teacher you tried than to basically have erased all your attempts and then have a blank question, which then the teacher can't give you any credit for. Because every now and then you might get almost all of the points because all you did was a really silly mistake like multiplying wrong or subtracting wrong or something. But otherwise, everything about your equation was right. So, yeah. Okay. Is x equals 1 a solution to this equation? This one's a little bit more complicated on purpose because I do want us to think about order of operations, but the very first thing we're going to do is put the 1 where the x is on both sides. And this is an important skill in general. We don't just end up using this for checking our answers. We end up using this for other things as well. So we do what's inside the parentheses here. We do the multiplication and then we subtract the 1. So 2 times 1 is 2 and 2 minus 1 is 1. So I'm going to do 7 times 1 on this side. Here I've got 3 times 1, which is 3, and then I'm going to do minus 4, which, if you're not paying attention, you could actually get this wrong, right? 3 minus 4 is negative 1. 3 plus 4 is 7. So with wishful thinking, those would be the same, but they're not. 3 minus 4 is negative 1 because you're subtracting more than what you have. So that's not equal, right? So we would say, no, this is not a solution. Now, this doesn't tell us in the context of this problem anything else about the solution. It doesn't even tell us if there is a solution. We would have to solve it ourselves to figure that out. And I completely made this up, so I'm not even sure if this works out to a nice answer. So you may not want to, go down that road unless you just really want to. But that's how we can check our answers to see if we're right. On our worksheet, there is going to be some practice of this so that you can get the hang of it before some highly critical time like a quiz or a test. All right, it's that time again, challenge time, and nobody's answered any of my challenge questions, so I don't know if people like them or not, but I guess I'm just going to keep doing them until I get tired of inventing them. And just like this last time, this is going to be what we look at in the next lesson, the next video. So what do we do when we have an equation that has fractions, or if it has decimals? Do we do anything different? Do we do it the exact same way? Well, you'll have to look at that video to find out. But the short answer is yes. You can do it the exact same way. But we also do have something that we can use to make it easier. So it's like both of those were the right answer. I don't know, maybe. But give this a try if you'd like to. If you get an answer or just want to comment on it in general, that's what the comments down below are for. Hey, thanks so much for watching. I hope that you liked it. And if you do like it, you should like it, as in with the thumbs up button. Feel free to subscribe, comment, do all those cool things that YouTubers are always telling you to do, because I am in fact a YouTuber, believe it or not. That's why you're here watching me. I will see you in the next video, hopefully on Algebra 1. You can check out my website for more resources. I'm doing a whole set of Algebra 1 curriculum with videos, notes pages, worksheets, solutions, and extra practice and everything. So definitely check it out if you'd like to. And thanks for watching. Bye.